Components of vectors. The vector, A being the diagram, is just a column vector. It goes 3 units and 4 units that way, and I quickly did that by subtracting. And of course we can go from A to B by going from A to X and X to B, just like we did before. But this is important. We can get two important vectors that are called I and j. I being the vector of unit length in the positive direction of the x-axis, and j being the vector of unit length in the positive direction of the y-axis. And therefore, using column vector notation, we have I is 1, 0, remember that's the x, and j equals 0, 1, remember that's the y. That's very important that we understand that I is that way and j is that way. Okay. Now, component form. We can write the vector in component form. So with this u vector is x being with the I, because it's going in the I direction, and y being with the j. We say that u is the sum of two components, the sum because we're adding them up, xi and yj. The magnitude of the vector, we get the x and the y values, square them up and add them and square root, and we denote the magnitude by that. And then of course, because we can put them with the i's and the j's, it's just like adding them together like normal algebra. Example 7 says if find AB if 0a is 3i and 0b is 2i minus j. So part A to B, we must go from A to 0 plus 0 to B. 0 to B we've got. A to 0 we don't have, we've got 0 to A. So A to 0 is negative 3i. Remember the opposite direction, plus 2i minus j. Now we can collect like terms. So we can collect those terms together, and we've got minus I minus j. And that's our A to B. Part B. The magnitude of 2i minus 3j. So to find the magnitude, we're going to get x squared, which is the 2 squared. We're going to get the y part, which is negative 3, square them, add them up and take the square root. So we've got the square root of 4 plus 9, which is the square root of 13. There's a magnitude of that. Example 8, let A and B be points on the Cartesian plane so that OA is 2i plus j and OB is I minus 3j. Find the magnitude of vector AB. Vector AB will be A to 0 plus 0 to B. So A to 0 is the opposite of that, so the negative part. So we can have minus 2i minus the j, and O to B we've got, so plus the I minus the 3j, and again we collect like terms, so minus 2i plus the I, and then we collect the j's together. So minus 2i plus the I gives me minus the I, and minus j and minus the 3j gives me minus 4j. Now I can take out a negative if I want, I don't need to. Then the magnitude from A to B vector will equal the square root of negative 1 squared, because there's a 1 in front of the I, and the number in front of the j is negative 4, so minus 4 squared. So I've got 1 plus 4 squared is 16, which means I've got the square root of 17. Unit vectors. A unit vector is a vector of length 1 unit. For example, both I and j are unit vectors. A unit vector in the direction of A is denoted by A with the witch's hat. And we say it's a hat. Since A with the witch's hat equals 1, we have the final thing, unit vector will be A divided by the magnitude of A. Example 9. Let A equal that, find the magnitude of A, and hence find the unit vector in the direction of A. So magnitude of A will equal the square root. The number in front of the I is 3 squared. Number in front of the j is 4, so we've got to square that. So we got 9 plus 16, so we've got the square root of 25. So the magnitude of A equals 5. We don't worry about negatives here. And the unit vector is A divided by its magnitude. So it's 1/5. And then the A is 3i plus 4j.